Okay, so today I'm going to be talking to you about some of the analysis work that I did this quarter on this project called Polaris, which is a planning scaffold that really thinks about how to support researchers in creating and evaluating their design arguments when they're doing design-based research. Just to kind of paint a picture of why this is important, to solve the complex problems that we face in today's world, we really need effective and scalable ways to train novice innovators in leading creative work like design-based research. Novice innovators really need help from expert mentors to develop the types of skills they need to do this type of work, but there are limited mentoring resources and access to expertise, which make it really hard to support this type of really effective and scalable training for these novices. So there's this model called Agile Research Studios, which provides a structure for a faculty member to train 20 or more novice undergrad researchers in leading independent research work. And this, like the students in these ARS settings, lead and perform all the core research tasks from beginning and end. So from the design to the implementation of the systems that they're building to evaluating and testing those systems in the field to writing up the findings about the effectiveness of their systems. So the ARS setting is designed to really support and train these students in the metacognitive tasks required to do this type of research work. For example, like being able to effectively plan out their research. For example, the students in ARS participate in these weekly SIG meetings with mentors and peers to talk through the progress that they've made, to surface blockers that they might be facing in their research, and to plan next steps to address them. We found that students struggled to really identify issues in their design arguments in these meetings. So design arguments are these problem representations of the outcome that a student wants to achieve with their research work, the challenges that their users might be facing in realizing this outcome, the proposed characteristics of a design that the student believes could really help with these challenges that the user's facing, and arguments for why they believe this design could be effective. Literature shows that the way experts think about planning next steps in design work is by actually identifying specific issues they need to address within their design arguments. And what we found was that in our when we observed like through preliminary studies, when we observed approximately 10 different mentor meetings, that within these meetings, students were still largely relying and depending on their mentors to help them identify these critical issues, which they used to kind of focus their plans. And what we learned was that in this process, the existing ARS model, the Agile Research Studio model, was really lacking ways to explicitly guide students in forming and evaluating design arguments, which would help inform their next steps and help them plan out their research, and therefore lead their research more effectively. So to help with this challenge, we introduced Polaris, which is this system that is a planning scaffold, and it helps these novice undergrad researchers really think about how to construct and evaluate their design arguments, and it embeds kind of expert practice within the tool. So it's composed of, you can see on the left here, a design argument template, which takes the 4 components of the design argument, the outcomes, obstacles, characteristics, and the argument, and lays them out in this template that students can fill out. So it lays out these components, and then it also provides these visual links that emphasize to students that, well, your obstacles should really be related to your outcomes, and your characteristics should be written in such a way that they are addressing the particular obstacle that a user is facing. And in addition to the template itself, we also, within Polaris, include sidebar prompts, which you see on the right-hand side. And these prompts were derived from the questions that mentors found that they were repeatedly asking students in these mentoring and coaching meetings. These are kind of like the types of questions that mentors ask, and we encoded them into these prompts that are meant to scaffold students in assessing and really just like evaluating their design arguments as an expert would. We had conducted an initial experiment on Polaris to kind of understand its efficacy in helping students construct and evaluate their design arguments and how that might compare to mentor performance. So in the initial experiment design, there was this first part of the experiment where students generated their design arguments using the Polaris template. They then were asked to create a list of issues that they saw in their design arguments without seeing the sidebar prompts, after which they used the sidebar prompts and then were asked to again try and create a list of issues that they saw in their arguments after having used the prompts. And those are sort of like the important details of that first part. Separately, mentors were asked to independently generate issues for two of their own student teams that they were mentoring, having not seen the issues that the students generated. So they were looking at the student design arguments and then generating issues, and then rated how critical they felt those issues were, to get kind of like a mentor baseline of, given these design arguments, what are the critical issues. In a second part of the experiment, the mentors went in and actually assessed the issues that the students had generated and rated them on a scale of 1 to 5 on these different dimensions of criticality. So how accurate they were, how severe they were, how articulate they were, and how actionable the issues were. Mentors then went through this task of trying to come up with different diagnoses and pieces of feedback for students based on the issues that they generated. And and both mentors and students, as part of the part 1 and part 2 of the experiment setup, just kind of reflected on their experience using the tool. So this quarter, what I spent my time on in terms of this project was really trying to understand what were the claims and pieces of evidence that we were able to make before, based on the analyses that we had already done on Polaris, and what are some remaining questions that we might want to ask in the space that we don't yet have evidence for, as a way to kind of build up next steps on this project, and also as a way to build up next steps on this project. So there were sort of like two primary sets of claims that the original paper structure that we were trying to make in the original paper structure. So one was that students could use these prompts in Polaris and the Polaris template itself to really generate these substantive issues within their design arguments, because the prompts are kind of serving as this scaffold to help students evaluate their design arguments as a mentor would. And for that claim, the findings that we had from our initial analyses were that students were able to identify issues that were related to design arguments, that students were able to identify issues that kind of went across the different components of a design arguments and were distributed across these different pieces, and that when comparing the types of issues that mentors and students generated, that there was some similarity generally between mentor-generated issues and student-generated ones. The second part of the experiment was really focused on, well, if if Polaris is helpful in students being able to generate these issues that are important for being able to have conversations about what are the next steps in the research, then um, to what extent are mentors able to use student design arguments to um, be able to kind of diagnose specific misconceptions that students might have about design arguments themselves or maybe elements of their research project, and to what extent can it actually help them coach students in planning next steps. And for that slice of the paper, we were really thinking about in terms of findings, mentors showed that they when they assessed the student generated issues, that the student generated issues were highly critical along the 4 dimensions, which you could see on the far right. We also found that mentors were able to use design arguments and the issues that students generated to be able to diagnose misconceptions, and they were able to diagnose different types of misconceptions on 40% of the subset of issues that they looked at. And we also found that mentors could use those design arguments to suggest these next steps that students could take, that they could use in coaching discussions. And mentors were able to identify these specific next steps on 63% of issues, which was cool. Given the experiment setup and design, there were a lot of different additional analyses that we could have conducted with the data that we collected. And in addition, there were a couple of different questions that we have about this space in general that were not captured by the experimental design and might require additional study design and data collection and then analysis to really answer those types of questions. So I spent a lot of the quarter kind of expanding out the claims that we might want to make in this space as a way to kind of help me plan out next steps for what types of analyses we might want to do next. And so just kind of like for the sake of like the process and the what I worked on this quarter, in green were some of the analyses that we couldn't do with existing data, but are the types of claims and findings that we might want to make in this space and might require additional experimental setups. And in blue are the finding statements that I kind of like hypothesized that we might be able to make given the data that we've already collected, but we aren't yet able to make because we haven't done the analysis yet. And so I scoped my work for this quarter to really focus on some slices of the looking at the existing data and answering some of these questions that we really wanted to know the answers to. So specifically, I focused in on the use of the Polaris prompts themselves. So since the experimental setup was really designed as like this sort of pre-post of how students generated issues using the Polaris template, first without the prompts and then with the prompts, I thought it would be interesting to kind of think about, well, how did student issues compare when they generated these issues without prompts and then with prompts. So specifically, I was also interested in how are the prompts themselves actually changing how students are thinking about issues in their design arguments. So so for example, like, let's see. There might be ways in which I guess we were curious about like at a high level the prompts themselves. It makes sense that if students use the prompts that they would come up with, for example, like better types of issues, but we were curious about what the prompts were actually doing in terms of changing how students were assessing their issues, and what were those prompts designed to do, and how did we see it affect the types of issues that students ended up generating. Kind of similarly, how to what extent were the prompts really able to help students evaluate the different components of their design argument, and perhaps there were ways in which the prompts were really helpful in some areas but not as helpful for others. And then finally, what are were there issues that the prompts were really helping students with, that when they tried to look at their assess their design arguments without the prompts, it was really hard for them to catch those issues on their own. Okay, so I wanted to kind of jump into the analysis that we did. So let's see. One of the first tasks that I did was really relating back to the prior work that we had done. We had been working on a similar project in another design studio setting. These students weren't doing design-based research, but they were working on human-centered design projects. And within the process of that research, we were really trying to identify what are the common types of issues or risks that students come across in their design work in these different dimensions of their project. So the language is a little bit different, but there were some commonalities in terms of for example, the way in which these design students thought about root causes could be mapped to the way in which ARS students were thinking about obstacles in their design, and the way in which these students were thinking about their value propositions for what they believed would be an effective design could be similar to the way in which students in the ARS setting were thinking about characteristics of their proposed designs. So we were curious to see if we were trying to argue for what the Polaris prompts are trying to achieve and what are they actually trying to assess, if there was actually commonality between the way in which the prompts are designed and these types of risks that were common to students doing design work. So one of the first tests that I did was just kind of going through the Polaris prompts and coding them based on the relevant sections from these common risks and using those as codes from prior work. I did this coding task, and then Spencer, one of my co-authors on the other work, conducted the coding task as well independently, and we kind of exchanged notes and had a meeting to discuss what discrepancies we saw in terms of applying these codes to the Polaris prompts. And the high-level takeaway that we had, so I guess as a caveat, I do still need to look at explicitly what were the differences that he and I had in terms of the way in which we coded. But after a quick debrief immediately after both of us finished coding, our kind of high-level takeaway was that it seems like the common risks that students encountered in the human-centered design project space were less specific and in less detail than the what the Polaris prompts seemed to be trying to assess in an ARS student's design argument. So I guess as a concrete example, one discrepancy that we both found was when an ARS student was trying to assess their obstacle, one of the prompts asks, is the statement of the obstacle something that is concrete enough to be measurable or observable. And the closest thing to a type of mistake that, or a type of issue that a student would make in the design setting was that they didn't really have any supporting evidence for a root cause that they might have listed. So the difference here is that the type of risk here, as it's articulated as like one of the root causes, to have no supporting evidence is more assessing sort of like the like after they have like after the students had tried to articulate the obstacle, it's assessing whether or not they actually had evidence to support if the obstacle was real. But it's that's sort of like an after the fact assessment. Whereas the way the Polaris prompt is actually designed and written, it's designed to help a student think about how they're planning. So it's asking them if they believe the obstacle is something that could be measurable or observable. So it's actually helping them think about if they need to refine their obstacle to improve its measurability before they do the task of measuring whether that obstacle actually exists for the user. I need to do a little bit of a deeper analysis to understand concretely the ways in which these Polaris prompts are different, and maybe providing a different type of value for supporting students in assessing. But that's kind of like a next step of the research. So given that we saw a significant enough misalignment between the types of issues that this prior work was talking about and the way in which the Polaris prompts were designed, I focused my coding task of student issues on using the Polaris prompts themselves. So in order to kind of actually to help a little bit, I feel like I'm jumping back and forth. If one of our goals was to really understand what's sort of like the difference between the types of issues that students were able to generate without the prompts and then with the prompts using Polaris. One of the tasks I thought would be helpful and important to do in terms of analysis was to look at each of the student issues that they generated and code them based on whether or not I felt like the issue that they raised aligned with a very specific prompt within the Polaris template. So on the left-hand side here, you could see the different student issues, and then on the right-hand side, these are the types of prompts that Polaris provided. And I also included codes as to whether or not, like if the issue wasn't matching to a specific prompt, was it generally about the outcome, obstacle, characteristic, or argument, or was it about something else entirely? So the way I went about this coding task was I actually did it blind in terms of whether or not the student issues were generated with or without prompts. So I just went ahead and hid that column for myself, and then assessed the prompts without knowing whether or not students had generated that prompt, or assessed the issues without knowing whether or not the students generated those issues with or without the prompt. So from the analysis, some sort of like high-level statistics that I thought were really interesting. In the prompt condition compared to without using the prompts, the number of issues that students generated were roughly similar. What's interesting though is, well, I guess, okay, so we'll start with when when students use the prompts, the number of issues that kind of aligned with these specific prompts themselves or were generally about the design arguments were quite high. So of all the issues that students generated using prompts, over 95% of them were either related specifically to the prompts or generally about their design arguments. Again, in the setting where they use the prompts, the percent of issues that specifically aligned with prompts was 84%, which is huge. So I guess in contrast to the setting where students were using Polaris and then generating issues without having seen the prompts, the number of issues that aligned with specific prompts was 53%. So we see a 30% jump here in the setting between in this setting here in the without prompt condition, whether or not they aligned with specific prompts, and then the with prompt condition, whether or not they aligned with specific prompts. So one of the questions I had was, well, this percentage is still quite high. Like the fact that students were able to, like of the issues that they generated without prompts, that 53% of them still aligned with the types of things that you would see in the prompts themselves. And so I think I think this is actually a pretty realistic finding, and an important detail about the experimental setting is that these are students that were previously trained on the concept of design arguments and had gone through a series of lectures really explaining what design arguments were, and how to think about evaluating them and measuring them. So these students are familiar with types of issues that they might encounter in their design arguments just from having gone through those lectures, having practiced design arguments, and having been exposed to this learning environment where they were practicing them on their own project. That being said, we still see this significant jump where when we introduced the prompts, that students were able to generate, like that there was this kind of 30% jump in the number of issues that they could generate that were really specific and aligned with these prompts, which they weren't able to do in the setting without the prompts. Okay, so let's see. The other interesting difference that we see in these two conditions is when students were in the setting when they were using the prompts, they didn't really have as many issues that were sort of like general design argument issues that didn't specifically map to a prompt. So in the with prompt condition, we saw just 11% of the issues that students generated were kind of these like other general categories where like it was generally related to the design argument, but it wasn't connected to a specific prompt, or it was just something else entirely. And the something else entirely was quite small. It was around just 4% of the issues. What we saw in the condition where students were not using the prompts was that a much more significant proportion of the issues that they generated were falling into this category of, well, it's generally about the outcome, obstacle, characteristic, or argument, but it's not actually connected to these specific types of prompts or issues that we see. So 40% of the issues that students generated without prompts fell into this sort of like general design argument category and were not connected to specific prompts. So the big change that we're seeing between these two conditions is that there was a large shift in the like general types of issues that students were able to raise about their design arguments to these like very specific issues that actually aligned with prompts, which get them to reflect on specific ways in which, for example, the outcome of their design argument might have particular risks or issues within it. Which, like, statistically I found was really interesting and cool. I then went and looked at the specific, looking into the details of the issues themselves. I was kind of curious about, were there particular prompts that, what's another way to say this? Were there, in the condition where students used prompts, which prompts in particular were really helpful for students catching issues that they didn't tend to catch without prompts, and vice versa? Which issues were students able to catch without prompts, so that they were actually pretty good at catching the issues without the prompts, and introducing the prompt didn't, may have had some impact, but was not, that they were actually, before having seen the prompt, were actually performing pretty well in terms of being able to recognize that as a risk in their argument, if that makes sense. So these color codes that you see at the top, we'll go over the green issues first, but the ones that are tagged in green are ones that students were actually performing pretty well in before the prompts were introduced as an intervention. So in the without prompt condition, these students were actually pretty good at catching this type of issue in their own design arguments. So the first one is for the outcome in their design argument. Is it written as something that could be measurable or observable? And we saw, if you look at the tallies below, that without the prompts, of the 18 instances where students recognized this as an issue, 11 of them were cases where students were actually able to catch this without needing to see a prompt. They just saw the outcome in their argument and recognized that it was not measurable and logged that as an issue. The prompts did help students, more students catch that as an issue, but it was just kind of interesting to see that this was something that students actually performed pretty well in before. The other types of issues that students performed better in without prompts were, like we said before, these general types of comments where, as an example, we could look at, for example, this one, where the student is commenting that the design argument seems circular and that the outcome seems to be the same as the task item, where they're kind of commenting and critiquing on the outcome generally, but it wasn't actually quite clear what their specific critique was, and it wasn't clear that it mapped to a specific prompt that was given in Polaris. Which makes sense. It makes sense that we would see a lot more issues in this other general space and not related to the prompts in the setting where students were not using the prompts. So that makes sense, that aligns. The other thing that's interesting that we can see from this data is what are the types of issues that students really were not great at catching without prompts, and when we introduced the prompt as an intervention, it actually really made a difference in them being able to catch this type of issue. So the ones that were really salient are the ones that are in orange, and then the ones that we saw kind of like a bump in maybe 3 issues were in yellow, but I'll go over the ones in orange, so because I think those are the most interesting. So in the with prompt condition, students were much better at catching for their outcome, whether it's an example of what the stakeholder would actually want the user to be able to do. They were much better at catching, given what you're able to observe for the outcome, can you actually know from that whether or not you've addressed a core tension? So there were, let's see, actually if we filter by this one, so you can see a lot of the issues that students came up with in this category. Most of the times they needed the prompt to do it. But there were some really good examples in here. So for example, let's see. Yeah, so for this one, yeah, I guess this is kind of self-explanatory, but that the issue that the students recognized was that they're not actually kind of like measuring a pre-post to see if there was some sort of impact on the participants' behavior for the same task. So if that's true, then there isn't really a way that their outcome is telling them whether or not the obstacle was overcome and if they've addressed the core tension. Which is really cool to see that the student's able to catch that issue themselves just by constructing their own design argument and reading a prompt to help them assess that within their argument. Okay. Okay, and then finally, another one that seemed to really help students catch issues that they weren't really able to do without the prompt was this explicit prompt within the argument section asking them if their argument actually explains why the characteristic overcomes the obstacle to reach the desired outcome. So if we, let's see, if we look at these examples, a lot of these are students being able to kind of highlight specific ways in which their chains are breaking down that align with this prompt. So for this project and this issue, students recognize that the characteristic, they weren't actually explaining why the characteristic itself was overcoming the obstacle. So they're recognizing that their argument was not sufficient. So they're not detailing the ways in which it's not sufficient, but the fact that they recognize that as an issue is still pretty significant. Okay. All right. So, the other thing that we found was interesting and was kind of a question that we had was, is it possible that by providing students with a set of prompts, it might have overly constrained them and had them focus on a particular set of issues, and that they weren't necessarily thinking of issues outside of that scope that might still be critical issues for a project, but just weren't included in the prompts. And we actually saw an example of this, which I thought was really interesting. Okay. So I'm going to filter based on issues that were kind of generally related to outcomes. And one theme that we saw over and over again in a couple of the different student issues was a couple of students, as they were writing out their design arguments, realized, well, I'm writing out this outcome, but it's actually a characteristic. This isn't the outcome itself. I'm kind of embedding the characteristic within my outcome in my design argument, and I'm not separating those out. Which is a common mistake that I've seen students make in the past, and wasn't necessarily encoded as an explicit prompt within Polaris. But it could be sort of like a blind spot of the Polaris prompts, and something that would be worth adding into the prompts if it is a common and consequential type of issue that students do run into. That's the one salient example that I did see. I'm curious to kind of dig deeper into the analysis to see if there might be other types of issues that of these kind of like other general categories. Are there issues that students were able to catch, particularly in the setting where they weren't looking at prompts, that are actually important issues to catch in design arguments that would be good to encode as a prompt? Okay, so that's kind of the progress that I made with the existing analysis. In terms of next steps with the project, there's, as I mentioned before, there's kind of like two phases in terms of next steps that we could think about. So one are the additional questions that we might be able to answer that we really are curious about given the existing data. So one of those are there sort of thinking back to the experiment setup and the fact that mentors were also looking at student design arguments and kind of generating issues independent of seeing student issues. Are there common issues that mentors were able to catch in that assessment that aren't actually encoded into the prompts that we might want to encode to kind of inform future design? Another question that I thought would be interesting to answer are were the critical issues that mentors identified. So in that mentor assessment where they identified issues themselves, they rated them as, oh, I think this is critical, or a higher priority compared to this other issue that I identified. We're kind of curious to see how the critical issues that mentors identified were similar or different to the critical issues that students identified. So mentors also looked at the student issues and kind of assessed how critical they thought the student issues were, but we're curious about sort of the overlap and criticality between mentor-generated issues and student-generated issues. In terms of questions that we have that we would really like to see answers to, but might require new experiment design or additional data collection, one thing I'm really curious about in the future is how does this kind of shared language of design arguments between a student and mentor and creating the shared representation change the ways in which mentors can actually diagnose misconceptions and help students plan next steps. So for example, I think it'd be really cool to look at the ways in which dialogue between mentors and students is changing, and to what extent, for example, in mentoring meetings, are they spending more or less time trying to identify the issues and risks themselves with students versus saying, having concrete coaching discussions about, well, you think this is the issue, but actually this is the deeper issue, or we agree that this is the issue and these are some ways in which we could think about next steps. So I'm really curious about how, what effect this idea of design arguments has on the ability for mentors to coach in these design meetings, in these feedback meetings where they're talking about planning next steps. Similarly, I'm curious from the student perspective, the ways in which it's changing how students think about asking questions in these feedback meetings. So for example, are they kind of thinking about more specific questions and coming into meetings, thinking about the issues in their project and asking specific questions on issues that they've already identified? Or I guess like what we used to see before was students kind of coming into these meetings and talking about issues across the board on their project, anything from like a bug that they encountered to um, challenges in finding somebody in the community to get help when they were stuck. So I'm just kind of curious about how it's changing the way students are using their planning meetings and framing the ways in which they're asking for help and kind of leading that time to get the help that they need on planning specifically. Uh, yeah, so that's kind of what I think that we could do in terms of next steps. I will probably focus on doing the analyses that we can do with existing data first, and go from there. Thank you.